This is another edition of Kung Fu Physics. We are working our way currently through practice physics GRE problems. The one I want to do right now is number 59 off of the 2001 Physics GRE. It is a very interesting problem. This has always been one of my favorite physics GRE practice problems, actually, because it is kind of a chameleon. It's masquerading as an electrical circuits problem, but it's not an electrical circuits problem. So let's go ahead and go into it. As usual, I'll just quickly glance at the answers. Answers are fairly puzzling at this point. It's just this kind of table, so it doesn't help me much, and I move very quickly right into the text of the problem. Number 59. For an inductor and capacitor connected in series, the equation describing the motion of charges is, and then it's L d2q dt squared plus 1 over cq equals 0. It's a, differential equation where L is the inductance, C is the capacitance, and Q is the charge. An analogous equation can be written for a simple harmonic oscillator with position x, mass m, and a spring constant k. Which of the following correctly lists the mechanical analogs of L, C, and Q? So there are a couple ways to do this. One is to immediately start plugging in those answers and see what is popping out. So that's not a bad way to do the problem, and honestly that's how I started the problem. I started with answer A, and then I kind of, after I did that, I backed up and said I know what I need, and I'm going to try and do it that way. But so let's just kind of do it that way. If plugging in the answers works for you, that's fine. So anyways, you would just go in and plug in. So for answer A, for example, you would plug in M where you see L, and then where you see a C, you would plug in a K, and then where you see Q, you would plug in an X. X equals 0. And so I love how this equation, that's this scary looking, I mean, it's not scary if you're a big electrical circuits person. I'm not a big electrical circuits person. I got a lot of reviewing to do. And so honestly, just glancing at that problem, I'd kind of get a little panic attack going because I'd think it was a circuits problem, but it's not. It evolves into this. You plug in an answer, and all you're doing is saying, well, is that the form of a simple harmonic oscillator? And so, what is this? This is an acceleration. If I want, if it's easier to see that in my head, I can do an acceleration. And then over here I can do, I can manipulate that. ma equals negative x over k. Is that Hooke's law? Is that something that looks like a harmonic oscillator? Almost. It's almost there, right? What I would want, and at this point I looked at that first answer and then I started kind of working backwards. I said, ooh, that's close, but I want a spring. I want a spring, and what I know about a spring mass system and a harmonic oscillator is this. I know Hooke's law, right? And so from there I get, this, and then I can get, what is an acceleration? Just that. And if I want to do it that way, I can. And so at that point, I realized that's what I was looking for. And I wanted to pick out of that table the right answer that would get me there. And so I just, or just looking at what we had before, what I had up on the board before, you could see it was close, but it was not right off. It was not quite on, but answer B is quite on because K was underneath X in the other answer, in answer A, and I just want it, you know, multiplied by x. So the answer pops out pretty quick there. I think it's kind of an easy problem. I'm struggling with any more commentary on it, what to tell you about it. I mean, it's an interesting problem in that it is sort of a problem in disguise. It's a mechanics problem. You could even argue it's almost a math problem, a differential equations, how familiar you are with different types of different differential equations that represent physical situations. And this problem is showing us that obviously the same types of differential equations that describe this circuit also describe a harmonic oscillator, a simple harmonic oscillator mass spring system. So that's all it's quizzing you on, potentially a very quick, well, probably average time consumption problem, but pretty easy. I mean, you can see that once you get to there, you could probably be very confident in that answer. So we would pick answer B for this problem, and there you have it. That's number 59 off of the 2001 Practice Physics GRE. Thanks for watching.